Imagine the year is 2045. A small group of scientists using the world's most powerful laser send a series of bursts into space. It's a beacon for any intelligent alien civilization to see. And for years, it is greeted with silence. Then, it happens. A large, fast-moving object is detected entering the solar system. It speeds toward Earth. For some, it is cause to rejoice. Humans are not alone in the universe. Others panic. Have we announced our presence in a galaxy of hostile invaders? The day of reckoning finally arrives. Could this really happen?
What we all want to know is our kinship to other life forms elsewhere in the Milky Way galaxy. Are we alone, or are there brethren out there among the stars?
T-minus 10, 9, 8, 7...
Surprisingly, many scientists now believe that intelligent creatures truly are out there.
Ignition, liftoff.
And we're even close to finding life in our own solar system.
We're really moving rapidly in our search for life. We're very close to finding solid evidence for life on Mars and perhaps other planets in the universe. This is happening a lot more rapidly than I think people understand. Could be 2 decades or 3 decades, but it's happening in our lifetimes.
Atmospheric entry on my mark. 5, 4, 3, 2, 1, mark.
May 2008. The search for extraterrestrial life took a huge step forward when the NASA space probe Phoenix arrived at Mars.
Standing by for reacquisition by direct to Earth.
Mission Control stood by 200 million miles away as it began its perilous descent.
60 meters, standing by for touchdown. Touchdown signal detected. And in sequence initiated.
Phoenix quickly began to analyze Mars' soil for water or other evidence it could support life. And it soon made an astonishing find.
We dug the first trench, and as we dug down about only 2 inches, there was a bright white surface area. And of course, scientists being conservative, maybe it's salt. Yeah, the white spot is right here.
But scrapings of the white substance mysteriously disappeared in a few days.
Salt doesn't do that. Rocks don't do that. So we were really sure we had discovered the ice layer.
For the first time ever, a space probe actually touched water on Mars. And on Earth, wherever there's water, there's life. But Mars is no Earth.
Mars is a dry, deserted landscape, frigid cold, sub-freezing temperatures, and no appreciable atmosphere. What a hideous place for life.
Under those extreme conditions, life seems impossible. Except that scientists continue to be astonished by new discoveries of life where it shouldn't exist, on Earth.
Some life forms live where there's no sunlight, no oxygen at all. Boiling water, alkalinity, battery acid kind of conditions. Nonetheless, they thrive. And the message these little critters are sending us is loud and clear, that as long as there's liquid water, The actual environmental conditions, the chemistry, the sunlight, the acidity, doesn't really matter.
The sheer tenacity of life on Earth has radically altered our view of where alien life might arise. The discovery of water, along with carbon, methane, and hydrogen on the red planet, means Mars has the building blocks of life. And this meteorite from Mars, discovered in 1996, reveals structures that may be fossilized microbes. Some scientists suspect that beneath Mars' surface, microbes could exist today. Space probes reveal other potential habitats where life could exist. On the moons of our solar system's largest planets, on Saturn's moon Enceladus, we've recently discovered geysers full of water vapor and organic compounds conducive to life. And something might live in the hydrocarbon oceans of Saturn's moon Titan. But a moon of Jupiter seems the most promising of all. It might support not just microbes, but much larger, more complex creatures. January 2030. A rocket takes off from Cape Canaveral. 7 years later, it arrives at its target. Long the subject of scientific speculation. Europa, the sixth moon of Jupiter. A lander, the most sophisticated one to reach the planet yet, begins its descent to the icy surface. It's about to make one of the greatest discoveries in the history of mankind.
This one's great.
Will we find complex life on Europa? Richard Greenberg thinks we may. He was a member of the NASA team charged with analyzing the baffling images of Europa's surface sent back by the Galileo space probe.
Yeah, the surface was really quite surprising. For one thing, there are hardly any craters on the surface. Europa is about the same size as the Earth's moon, but it looks nothing like it. There are lines all over the place. Great linear features that run for 1,000 miles or more. Almost all of these linear features consist of double ridges. In some places, there are double ridges crisscrossing over double ridges over double ridges. So it was very puzzling when we saw the surface. What were we looking at there? What did all this mean?
Europa's surface is a bone-chilling 260 degrees below zero. Scientists once thought it was nothing more than a barren ball of ice over 60 miles deep, encasing a cold, rocky core. But our understanding of tidal forces has changed that picture.
Here on Earth, when we think of tides, we think of the ocean rising and falling against the shoreline. But really what's happening from a planetary perspective is that the entire shape of the Earth is changing. It's elongating and stretching as a result of the pull of the sun and the moon.
The same thing happens to Europa, but on a much larger scale. Europa has the misfortune of orbiting Jupiter, the solar system's largest planet. Jupiter's massive gravitational pull stretches and compresses Europa so much, it generates heat in Europa's rocky core.
It's just like when you rub your hands together, the friction between your hands makes them warm. Well, that's what happens inside Europa.
As a result, scientists now believe that beneath the ice lies a giant ocean, twice the size of all of Earth's oceans combined. It could hold life similar to the microbes and worms on our ocean floor that feed off vents heated by the Earth's core. Still, many scientists believe that ocean is buried beneath a layer of ice 60 miles thick. But Greenberg thinks that it may only be a mile deep, allowing sunlight to reach water at the surface and provide energy for larger, more complex creatures. His evidence? He thinks the double ridges can only be formed by cracks in the ice.
Europa is sort of like an egg. It's like a raw egg. It's got an ice crust on the surface and liquid below. Well, imagine you changed the shape of an egg every 3.5 days, made it longer and shorter. What's going to happen to the shell? It's going to crack.
If Greenberg is right, when the ice cracks, ocean water is pulled towards the surface where it freezes. When the tidal force recedes, the crack compresses, pushing the frozen slush up. As the process repeats, the double ridges form. In the cracks and water below, could we find an ecosystem? Even fish-like creatures.
Tides on Earth produce zones like this tide pool that are particularly rich in diverse life. As the water flows in and out, it delivers nutrients, everything that life needs. Just as tides can support life in a tide pool on Earth, they may well support life in a niche like one of these cracks on Europa.
March 2040. Parked near the edge of an icy fissure, the Europa Explorer drops a probe with a camera into the slushy water below. Nuclear power heats the device, and it quickly breaks through to open water for the first glimpse into Europa's vast ocean. Back on Earth, scientists can't believe their eyes. They've entered the strange new world of extraterrestrial life. If life has evolved here, scientists are now confident it's evolved in countless other places in the cosmos. And somewhere out there, intelligent life must also exist. March 2041. A NASA team directs a powerful space-based telescope, the Terrestrial Planet Finder. In 2010, scientists had discovered only about 400 planets. By 2041, that's grown to over 5,000. Only 100 of them are small planets like Earth, and none host signs of life. But the planet hunters are in for a surprise when the telescope locks onto a new target they name Sigma 547. It's the same size as Earth, the right distance from its sun for liquid water, and it's about to revolutionize humanity's understanding of its place in the cosmos. Is Earth one of a kind? Or does our universe contain millions of planets that aliens could call home? For millennia, we believed that our planet was unique. Now, we're about to find out if we were right. One of the most powerful Earth-based telescopes in the world, here at the Keck Observatory in Hawaii, is going on safari. We only discovered the first planet outside our solar system in 1994.
What were we at Air Mass 2?
Before that, some astronomers suspected planets were extremely rare.
Wow, we're getting a lot of counts.
But now the count of planets orbiting distant stars is over 400 and rapidly growing.
DCD readout complete.
These coordinates will match those coordinates and will be locked in, and the star should appear here. Whoop, there it is. That's the star. First planet hunting star of the night.
Jeff Marcy, one of the world's leading planet hunters, has discovered over 100 of the new planets.
Planet hunting is raging on fire right now. There's interest in finding Jupiter-like planets. There's interest in finding planets that orbit stars that are just like our sun. And most importantly, there's a great push to find other Earths. Are Earth-like planets common? Are they rare? Are they a dime a dozen or one in a million? We just don't know.
The vast distances make finding planets still extraordinarily difficult. Our first advance came with the discovery that we don't have to see planets to detect them. Instead, we can search for the effect a phantom planet has on its star. An ever so slight wobble.
The most successful technique has been to measure the wobble of the star as it's yanked gravitationally by that planet. And of course, the more massive the planet, the more that star gets yanked around.
The largest planets that tug hardest on their stars are the ones that show up most easily in Marcy's data. Unfortunately, they're all hot gas giants, like our Jupiter and Saturn, with poisonous atmospheres. The most likely place to find an alien civilization is on a smaller planet, a rocky one with water, similar to Earth.
Engine start. 1-0 and liftoff of the Delta II rocket with Kepler on a search for planets in some way like our own.
Earlier engine. Check the pressures are built.
In March 2009, NASA launched a revolutionary new telescope, Kepler, that moves the hunt for planets off the ground and into space.
Kepler is capable of detecting Earth-like planets orbiting around tens of thousands up to 100,000 stars.
Like Earth, Kepler orbits the Sun. It contains a single large photometer. With its huge unblinking eye, Kepler stares into a large portion of the Milky Way, looking for planets the right size and the right distance from their stars to support life.
And here's the way it works. When an Earth-like planet crosses in front of a star, it will block a tiny amount of the starlight. Actually, 1/100th of 1% of the light of the star will be blocked every time the planet crosses in front. And that tells us the size of the planet, the diameter of the planet. Bigger the planet, the more light is blocked. Bingo, we get the size of the planet.
Scientists are abuzz with the possibility that within just a few years, Kepler will tell us if other Earths that could host intelligent life are rare or common.
My guess is that 60, 70, 80% of the stars you see in the night sky have rocky planets orbiting them. Maybe some of them are like Mars, maybe some of them Venus, others may well be like the Earth.
New telescopes are finding not just planets, but the building blocks of life. Water, carbon, nitrogen, even complex hydrocarbons everywhere. And we'll be able to detect them in the atmosphere of newly found planets. Our time alone in the universe could quickly be coming to an end. May 2041. Scientists discover signs of life in the atmosphere of the planet Sigma 547. Stunning news that's soon shattered by another bombshell. In the alien atmosphere, they detect a trace of a chemical, a chlorofluorocarbonate, CFC. This alien planet has industrial pollution, a sign of technology. Astronomers around the world quickly swing their telescopes into action, each hoping to be the first to capture an alien transmission. June 2041. In Northern California, the 350 dishes of the Allen Telescope Array lock on to the planet Sigma 547. and decades of work scanning the skies for E.T. appear to pay off. There's an anomaly in the static of space. Is this just a new natural phenomena? Or have we discovered a civilization as advanced as ours? What are the odds that the universe contains other civilizations capable of sending messages? They look exceedingly slim, until you consider the size of the universe.
You can do the numbers, right? There are a couple of 100 billion stars in our Milky Way galaxy, and the chances are that about half of them have planets. So let's say 100 billion stars with planets. How many planets do each of them have? Well, on the order of 10. We have 8. Say 10. So that's 1 trillion planets just in our own Milky Way galaxy.
If just 1 in 10,000 planets develop life, and just 1 in 100,000 of those develops intelligent life, that's still 1,000 societies in our galaxy alone. And the universe contains billions of galaxies.
Aliens should be here for a whole set of reasons. We know that the sorts of stars which allow solar systems to evolve are, in many cases, billions of years older than our solar system. So, in principle, life, evolution, and I would argue intelligence might have a head start of 3 or even 4 billion years.
If they're out there, and they've been around far longer than we have, what do scientists think might truly be possible? Could they be trying to contact us? Could we detect and decode a message from aliens? Astronomer Seth Shostak thinks we could hear from aliens in just the next few decades. Shostak's with SETI, the search for extraterrestrial intelligence. And a powerful new tool has come online that may tilt the odds in SETI's favor. The $50 million Allen Telescope Array in Northern California. It's the first radio telescope ever dedicated to the search for signals from aliens.
So there are about 42 of these antennas here now. The idea is to actually get this up to a few hundred dishes. They're 20 feet across, which is pretty small compared to other radio antennas, but in fact, because there's so many of them, the total collecting area, the sensitivity, if you will, is very, very high.
When it has its full complement of 350 dishes, the Allen Array will blow the doors off most existing radio telescopes. The main dish of each telescope focuses radio rays onto a smaller dish in front. Inside is an amplifier.
Now the amplifier that's over here is extraordinarily sensitive. In fact, there's some cryogenics here, cooling, to keep it at very low temperature, so it's even more sensitive. It is so sensitive that if somebody were to turn on a cell phone nearby, it'd probably fry the amplifier. So, no cell phones on site.
Already, the array generates a mind-boggling amount of data, almost a gigabyte a second. So much it can't even be stored. Instead, it gets worked over in real time inside.
This is kind of the machine room for the telescope. The antennas, of course, are outside. They're sending everything they collect back to this room via fiber optic. Now here what we do is we subsample some of that incoming data. We can't analyze it all. There's just too much. But we sample some small fraction of the radio dial, we combine it, and then we analyze the signals coming out of there, looking for something interesting. What you're looking at here is just the noise of space. Cosmic static, a little bit of noise from the receiver. No obvious signal in this. But every now and again, we'll pick up something a little different. And you can see right here a signal very clearly. This is such a strong signal you can see it with your eye. It's also visible over here. This, it turns out, is just a satellite. But this is the way a signal would look if it's actually ET's transmitted.
Finding a signal is like tuning into a station on the radio. In the early days of SETI, that's what astronomers did. Search through frequencies one star system at a time. Even after 50 years, the search has barely begun.
The problem is we've really only looked at a very small number of star systems over a very narrow range of frequencies. We've just barely scratched the surface looking for ET with this technique. Well, this antenna back here has the capability of searching hundreds, eventually thousands of times faster of anything we've done in the past.
Within 20 years of being fully operational, the Allen Array will be able to search for signals from 1 million stars as far as 1,000 light years away. 1,000 times more stars than we've ever searched before. Shostak is confident those numbers mean contact is imminent.
We haven't found any cosmic company yet, but I think that in the next 24 years we're going to pick up a signal that tells us that somebody's out there.
January 2042. For 7 months, supercomputers around the world have tried to analyze a strange radio pattern from the planet Sigma 547. But scientists can't make sense of it, and many become skeptical. Maybe it isn't a message after all, just a natural electromagnetic disturbance. Then, a breakthrough. A researcher who analyzes dolphin communication finds a structured pattern in the noise. Nobody knows what it means, but it's clearly a message. If someday we do detect an alien signal, will we be able to understand it? One language from the Easter Islands has resisted translation for over 100 years. And that's a human language.
I mean, think of the hieroglyphics, right? I mean, all these markings in stone on these walls in Egypt. We didn't understand them for a long time, but we knew that that was a message, that there was some meaning to those marks in the stone. On the other hand, if they're deliberately broadcasting something to Earth, maybe they'll make it really simple for us.
How do you construct a message that can communicate with a different life form? In 1974, astronomer Frank Drake used the universal language of mathematics. From the powerful Arecibo telescope, he beamed 1,679 laser pulses towards a distant star. That amount is the product of 2 prime numbers. If aliens plot the pulses using those numbers as columns and rows, they'll see this. A graphic that depicts, among other things, a man, our solar system, and even the population of Earth. Elegant, but not simple. Drake challenged his colleagues to decode the message, and every scientist came up with a different interpretation. If we receive a message from aliens, we may not be able to understand it. But the discovery would still change everything.
If the SETI people find a signal, it's going to completely revolutionize everyone's view of their place in the universe.
That would be one of the greatest existential discoveries of science. We'd be part of something so much bigger than is possible on the Earth.
October 2045. In 3 frustrating years, scientists have failed to decode a message from the planet Sigma 547. The UN has still not decided if we should respond. Then, a small group of scientists at one of the most powerful observatories on Earth decides to take matters into their own hands. Eager to communicate, they aim a powerful laser at the planet and send coded images and messages telling them about Earth. Someone or something is listening. Is it wise to send messages out to aliens? You may not know it, but we already do, daily, through television. Early broadcasts have already reached 10,000 stars. And some scientists are eager to communicate with aliens. Russian astronomer Alexander Zaitsev has used one of the most powerful radio transmitters in the world to beam radio signals directly at nearby stars. He believes we have a moral obligation to let other civilizations know they're not alone. Of course, taking the first step in any relationship is a risk. What if they're not friendly?
There are some people who even think it might be dangerous to tell aliens about whom you know nothing that we're here.
That fear is based in reason. On Earth, predators of all kinds are vital to the survival of the ecosystem. Why should it be different anywhere else? What if the aliens are predators and we are the prey?
The terrifying possibility is that the things out there are more like stormtroopers than people who take their children for a walk. And I think that's worth thinking about, because some science fiction has explored these terrible possibilities, that the things out there are exceedingly nasty.
Like the invaders in H.G. Wells' War of the Worlds, aliens may look at us the way we regard bacteria. But surely we have nothing to fear. Even if the most predatory aliens detect our signals, it would take them tens of thousands of years to reach us. Or would it? November 2045. It's been just a month since a scientist beamed an unauthorized message towards the planet Sigma 547. All is silent. Then a spacecraft on its way to Mars detects a pulsing light. A probe of unknown origin, beaming signals into deep space. Is an alien mothership far behind? Could aliens really travel here? Although unlikely, it's not impossible. NASA scientist Jeff Landis has been thinking about the technology that advanced aliens might use for a long time. He designs advanced propulsion systems for space travel.
Interstellar travel is tremendously difficult, and the real problem of it is the distances involved are just so immense. If we launched a probe today using chemical propulsion that went as fast as the fastest probes ever sent by humans, it would be tens of thousands of years before they even got an appreciable fraction of the way to the nearest star.
But theoretically, loopholes in the laws of physics could allow more advanced civilizations to travel much faster. According to the theory of relativity, if you could stretch the space-time behind a rocket ship and contract it in front, you could create shortcuts that would allow you to travel at unimaginable speeds.
So far, warp drive is entirely theoretical, and it's not something we know how to do yet.
The laws of physics also make it possible to create another shortcut in space-time, called a wormhole. But to make one, you may need to harness as much energy as a star produces.
They're possible in theory, but the question is, how could you make a wormhole? And the answer is we don't know.
Aliens may have looked hard at these exotic cheats in space-time for a very good reason. rockets have severe limitations.
Rockets have to carry their fuel on board. And this is what we call an exponential problem, because of course you have to carry fuel, and that's heavy. So you need more fuel to carry your fuel. Then you need more fuel to carry that fuel that carries the fuel. Pretty soon, the rockets get just huge.
But there are alternatives, including one Landis has been working on.
Is there some reason you have to carry the fuel with you? What if instead you could beam the energy to you?
That's the idea behind this, a galactic sailing ship powered by light, already being prototyped by NASA. The sail would be giant, perhaps 100 yards across, made from a familiar material, aluminized plastic, Mylar.
The real solar sail material would be even lighter than this, of course. We need to really minimize mass if we're going to make a spacecraft.
Aliens journeying by light sail wouldn't have to carry fuel. Massive lasers back home would beam power to their ship as it traveled between the stars.
It's certainly something we could imagine being feasible. Something that we could do with technologies that we understand today.
If aliens from Earth's nearby stars built a light sail, they could reach Earth in less than 25 years. It's even conceivable they may be able to create a rocket fuel of much greater efficiency. Antimatter. Humans' large rockets like the Saturn V use almost 1 million pounds of fuel to reach orbit. How much antimatter would they need?
The answer is less than 1 gram of antimatter. Less than the weight of a single penny. Pretty powerful stuff.
Although it's poorly understood, antimatter does actually exist. We even make it at the particle accelerator CERN, where scientists send protons moving at nearly the speed of light on collision courses. If the antimatter formed combines with matter, it's explosive. Today, it would take about 100 million years to make a single gram. But thousands of years from now, it may not appear as difficult.
We could certainly imagine alien civilizations that are just a little bit more advanced than us, putting together these antimatter-fueled rockets and moving among the stars, perhaps even coming here.
Oh my God. December 6th, 2045. Just 1 month after discovering an alien probe in our solar system, scientists detect a large object passing Jupiter.
Current velocity 12,084 miles per hour.
It's not an asteroid. The edges are too regular. It looks like a spaceship. The news spreads quickly. In capitals around the world, phones ring off the hook as generals and world leaders scramble to respond. December 7th, 2045. With an alien ship fast approaching, no one knows who speaks for Earth. Wild ideas about who we're about to meet flood the media as we prepare for unusual visitors. If we encounter aliens, many scientists think they'd look nothing like us at all. Their senses, their locomotion, everything would be different. But paleontologist Simon Conway Morris doesn't agree. Controversially, he believes they'd share many familiar traits with us. The clues are here on Earth.
When we look at the whole diversity of life, it's staggering. Tulips, tapeworms, elephants, sperm whales, fungi, what could be more different? But my argument is that, in fact, there's an underlying structure, if you like, to the tree of life, which makes certain outcomes either very likely or sometimes possibly even inevitable.
Where some others see a world of infinite variety, Conway Morris sees effective solutions, discovered over and over again. It's called convergent evolution.
I look at an octopus, the octopus looks at me. Now we know that the eye of the octopus is remarkably similar to our eye. It's built on a so-called camera design. Something like a camera eye has evolved independently maybe 7 times, and almost without exception, the animals involved are fast-moving, they are predators, and they tend towards intelligence.
It's not just eyes. Wings evolved on birds and on bats, even though they're separated by over 300 million years of evolution. This animal, captured in rare footage, looks like a wolf right down to its teeth. But it's a marsupial from Tasmania, a kangaroo in wolf's clothing. Conway Morris believes certain features evolve over and over again because they're the best solutions for living in our world.
Most of the things, in my experience in biology, don't work pretty well. They work fantastically well. For instance, the eye can, in principle, detect a single photon. Our ears can operate at the level of thermal noise. Noses can, in principle, smell a single molecule. And do you realize what that means? It means that we have got to the limits of the visible universe.
If Conway Morris is right, that has big implications for aliens.
The argument is really that evolutionary convergence provides, dare one say, a ground plan for life in the galaxy.
Find an Earth-like planet that has life, and given enough time, bipedality, precision grip, tool use, and most shocking of all, even intelligence will arise.
But if it's something similar to the Earth, then I'm hard-pushed to see why they won't have something awfully like a human. Not exactly the same, because of course it's a completely different evolutionary history. But one gets the sense that all those alien movies, where they did look surprisingly humanoid, was not a failure of imagination by us, but actually a biological reality.
So, do aliens really exist?
It's common as astronomers that when we're observing here to go out in the middle of the night and just look up at the stars. Every time I do that, I wonder if there's someone on a planet orbiting that star looking back at us.
There's billions and billions of stars. It's hard to believe that some of them don't have life.
Maybe the nearest advanced civilization is hundreds of light years away, maybe thousands of light years away. Surely they're out there.
In the last 30 years, the scientific case for the existence of intelligent aliens has become much stronger. And perhaps the biggest shock, if we ever meet our alien brethren, may be that they're not so alien after all.
If I'm correct, I would be almost ready to go across and shake them by, do you call this a hand?
December 8th, 2045. The world is riveted by the arrival of what appears to be a spaceship. As it approaches Earth, it splits in two and settles into position above each pole. Panic spreads when spaceships appear at equidistant points around the globe. Are they here to crush us? Enlighten us? Or like us, are they driven by the quest for knowledge and curious to meet their neighbors?